Alrighty then. So let's see. So I know everyone's paying attention right now. No one has earbuds in. No one actually is staring at their phone right now, and no one is walking up in here late because they had to go to Douche Bros to get the coffee. Because no one would do something like that, right? Right, Miss Johnson? Can she even hear me? Because like those earbuds are like super. Miss Johnson. Yeah, I'm talking to you. Take out your earbuds so you actually know what we're trying to do today. Thank you. All right. So this one right here is going to be a pain because a lot of people hate limits. They really do. So I'm trying to get everyone to pay 100% attention. This is the part where a lot of people screw up. Now, express a limit in terms of E. These things right here are already known. These number E can be expressed in two different ways. So we could actually take limit as h approaches 0 of 1 plus h to the 1 over h is equal to e to the first power. Now, what is e to the first power? There's a number. It's not 0. Yeah, it's like 2.7, blah, blah, blah. You can try it on your calculator. For those people that still try to use their calculator. I have no clue where my magic pen is. It's probably like right here under all my garbage. Hey, look, magic pen. All right, so right here. All right, E is an irrational number, like pi. It's one of those things that we have in math that excuse me, that is a constant that we use as a letter because it's always there. It always appears, it always comes up, and it is so constant we just use a number to represent that, like pi. Pi comes up in math so often that we actually have a symbol for it because it's irrational. Instead of trying to write it out, we want to be as close to exact on a lot of these things. Let's pretend like I'm an architect and I'm building a building with an arch. That arch is going to have a radius. And then if you know the formula for the circumference of that radius, or that circumference of that arc or arch that we have, if it's from a circle, it is going to be 2 pi r. So pi is a number you don't want to actually have approximated all the time. You only approximate it at the very, very end. So if I'm rounding it off at the very end, great. But if I round it off to 2.7 in the beginning, every step that I use 2.7 instead of using pi is going to get that little bit further away from what the actual answer should be. I want it as precise as possible. That's the reason why we keep using those symbols for these. So both of these actually give me E. So limit as n approaches infinity, 1 plus 1 over n raised to the n is equal to E, and it's technically just E to the first. if you're trying to put it in the calculator. That one over there is going to come up more often in calculus 2. So when you're actually doing sums and series and sequences, yeah, that comes up in calculus 2.
Do you know how to discover E?
I do not. Yeah, certain things I don't really understand.
Like pi makes sense, you know, like the circle stuff, but like E, it's different number.
I know but it's one of those things that it just keeps coming up over and over again. So I think at a certain point in math, they decided to start using that because it is a constant of it's always appearing. Kind of like golden ratio. It's always appearing somewhere. And so they have like terms and stuff for that. Yeah.
Do you think more mathematicians, like really high level mathematicians, are like agnostic or not?
Why would they be agnostic?
Like, I don't know, maybe like atheists or whatnot. Or do you think higher levels of math with that? Because that kind of stuff is like crazy to me. And it's like, I feel like if I were like.
Okay, then that goes back to your concept. Is math discovered or is it created?
So if someone believes it's discovered,
It's already there.
Think of it like that, yeah.
It's already there, and it's us and our understanding discovering our natural world around us and how we can actually fit it into our number sense. Does that make sense?
Yeah, but like, do you think on average, like more mathematicians are?
I don't know. Oh, even what's his name? Hawkins? Yeah. Even his last book actually said, hey, Big Bang Theory is great. Mathematical process actually does come out to it's called divine creationism. And so even though there was nothing and then it exploded, there's something mathematically that they have in the math that for that to work out, something had to start that. And there it is right there. So even in Hawking's last book, before he died, actually did say, you know what, there is something to this. So anyway, so right here, we're going to take this item right here, and people that are not paying attention are really going to end up hating me for this. So I need to make this one here look like the other one, which is the limit as h approaches 0 of 1 plus, was it n? Is that one n? No, h. Okay, h to 1 over h. I have to make it look like this. So what's different here? The 2h, right? So I have to try to get rid of that. Now, I'm going to go to another piece or another paper here because I'm going to need some room to actually work on this one. So it is 1 plus 2h 1 over h. So, and I currently have, so I'm taking, I'll make this in red so you guys could see this also, limit as h approaches 0, 1 plus h 1 over h is equal to e, the first, or just e. So there's this is what I'm doing. I know this value. I need to try to manipulate this to get this to be the same there. Right? Okay, so first thing I'm going to do, I'm going to try to take care of this right here. So it's got to be exactly the same. It's got to be numerically, it's got to be the same number, but it's going to look different. So I'm going to rewrite it. So I'm rewriting this. So I'm going to go back to black. So I'm going to change this. So now this is going to be 1 plus 2h to the 1 over 2h. Now, to make that true, what should I do to it?
Square it?
Perfect. Good job. By squaring it, didn't that actually take care of that? And now right here, h is any variable there, right? H is any variable. So it really doesn't matter. So if you had x, let's just use x as an example. So if x is some variable that I don't know, isn't twice x still a variable that I don't know? That's the rule that applies here. So right here is this and this the same.
Good morning.
Morning.
Do you have any?
I do not.
Okay.
One thing. So we're gonna do the cards again. Remember the light up cards, the holiday cards?
Oh yes.
And so
Car stock?
yeah, I have. This is what I have currently. So this is what I currently have.
Yeah.
So a little bit of blue, a little bit pink. So maybe a little more blue and anything else that you think.
He made me the cover for.
I know, but cardstock is a different thing.
What's it called again?
Curry.
Yeah.
Okay. All right. Okay, attention back up here, please. So we now have this and this matching, right? And now since those are matching, it goes with this right here. So I can now say all of this, the limit as h approaches 0 here, all this right here is going to be e. But what did I do to change this to make that there? I squared the outside, right? So I squared it to make it work. So now this is e squared.
Oh, so it's essentially the same thing as the U thing.
Yeah.
Oh, okay.
So my whole point is I'm trying to get, even though this is like x or 2x, it's still something I don't know. It's an unknown. So all this right here is I'm trying to get these here the same. Okay? All right. Let's look at the next one. So the next one is a little bit more complicated. And so I'm going to go on to the next page for that one. But my formula that I have for this one is, it is the limit as n approaches infinity, 1 plus 1 over n to the n is equal to e, like that. And you don't have to put e to the first power, but it's one of those things that I do myself, so I always see what it is. It's not, just the letter e. That's just a weird thing I do. So we're going to have to manipulate this to actually work. All right, I'm going to a new page for this one. Oh, it's not 1 over n, it's just n. The previous one was 1 over n. And then my problem, huh? Did I write it wrong? My problem is the limit as n approaches infinity, 1 plus 3 over n to the 2n. Did I copy that down right? All right, so what's the first thing I should try and take care of? Not the inside, let's work on the outside first. Because that's what we did last time too, right? So let's take care of that, because I gotta try and work my way in if I'm trying to manipulate this part right here. So I gotta get past the outside first.
So we're trying to get the 2n to just be an n.
Yeah, I want to do that, right? Okay, so that's good. So now the next thing I'm going to do, I'm going to manipulate this by going 1 plus 3n to the 2n. Actually, let's just go straight to it here. n Do you guys agree with that? Isn't that exactly the same? It's exactly the same. It's just, it goes out here now. Now, this is where the creative puzzle comes in. The creative puzzle. So now, what I'm going to do is, I have that 3 over n, and I have to try to make this one also be the same there. So what I'm going to do is, watch this. I'm going to go times 3 divided by 3. Is that still the same? Okay, it's still the same. Now, I'm going to show you, and I'm going to do a little bit of substitution so you could see what happens here. So I'm going to replace, because it looks kind of complicated here, so I'm going to say that k is equal to n over 3. So now if k is equal to n over 3, I'm now going to have a variable k up there, right? So my variable is k, my outside is 6, inside 3 over. Now, if k is equal to n over 3, and I only have n right here, right? Can I manipulate this a little bit? We know that k is equal to n over 3 isn't the same saying 3k is equal to n, isn't it? So 3k is equal to n. So 3k is equal to n, so I'm going to replace this one with 3k. I can cancel out the 3's. Now by doing that, I can now look at it and say, hey, I can now say that all this right here is going to give me that's going to give me my E, right? All that right there is going to give me my E, and I'm going to have an answer of E to the, yep.
Why did you change it to K? I know you did the, like, 36 and 1. Why did you do this and then this one?
I almost understood your question. A little bit louder.
Why did you turn it to K?
Why did I use K?
Yeah.
All right, so right here, see this? For my trick to work here, this and this have to be the same, right? Is this and this all the same?
But how
It's not the same there, is it?
so it wouldn't have worked if you had
It wouldn't have worked if,
you hadn't had substitute K there.
yeah, I used K to try to replace, so that's the reason why I divided it by 3, because I need to get rid of that 3. If this number right here was a 2,
Yeah.
I would have divided by 2 too, right? I would have done that, but it was a 3. And so I purposely manipulated that so I could substitute it over here also. So my first taking out the 2 took care of this piece right here, right? And then the second part, this 3, is me manipulating so I could try to get this piece in here.
Is there another way to solve it where you don't have to substitute or manipulate it to make it?
No, the whole point is manipulation.
Oh.
Yeah, that's the whole point of what we're doing here. Does that make sense or no? Okay. Do you remember when we were actually doing limits and we had a couple of things that it was identities that if you saw it, you knew what the answer should be? Like, what is the limit as x approaches 0 of sine x over x? Wow, okay. 1, yes. That's 1. Can I just plug in zeros? No, I can't plug in zeros. This one, if I try and graph it, what do I get there? It oscillates, right? It oscillates and it eventually comes out to right there at the very center. It's going to give me 1. So my manipulation would be similar if I had the limit as x approaches 0 of sine 3 x over x. What would I do with this one here? I want to manipulate it to try to make it into this. I want that.
Yeah, so you just multiply it by 3 over 3 and then it would become.
Multiply by 3 over 3. So it would go times 3 over 3. So multiply by the value of 1. So I'm not changing the value of my problem. I'm changing the way it looks. So by doing that, that's now going to give me my 3x over 3x. And so it's now going to be, all this is going to be, come on, sine of 3x over 3x times 3, right? So in the end, that gives me an answer of 3, because all this right here, because it's same here and same here, is 1. So 1 times 3 is 3. Same thing goes with this one. These ones are just more complicated. We're not substituting a 1 or something basic. This is an e. A little bit more sense or no? Nonsense. Is it just cray-cray? That cray-cray on the baked cake? All right. Anyway, let's use the rest of this time. We are going to homework questions that you guys have.